Hello, in this video we shall see how the height of pyramid was measured purely with the help of geometry in 5th century BCE. First thing to understand is the Thales theorem attributed to Thales. The theorem says that if there are two line segments which are intercepted with parallel lines, so this line DE, BC, these segments they are parallel and thereby creating two triangles. One is ADE and another one is ABC. Then the ratio of DE to BC, DE to BC shall be equal to AE to AC and which shall be equal to AD to AB. So the ratios are congruent. That's what the Thales theorem says. The theorem is attributed to Thales of Miletus, who was a Greek philosopher. He was pre-Socratic philosopher. So how was the height of the pyramid calculated? The first thing was Thales placed the pole and measured the shadow of the pole. This is indicated here. Then what he did was he the pyramid of Giza is a square shaped pyramid, almost a square shaped pyramid. So it was very easy to calculate one side of the square, and he divided one side of the square by 2. So 230 by 2 is basically the half of the side of the square, and then he added the shadow. Shadow was 65 meter. So what has been ascertained here is C, which is basically from here to here. So this distance he calculated and he called this distance as C here. Now we have the attributes A, B, and C. And now with the application of intercept theorem, we can calculate D, which is the height of the pyramid. So what he did was he brought this pole to this point, and he brought it in such a way that the shadow is exactly matching here. So the if he will bring here, then the shadow will be little bit going further, which is not what he wants. So he brought the pole exactly at the same place here, where the shadow is exactly matching the shadow of the pyramid, and it was done at the same time of the day where the initial calculations of the shadow was done. So now with this kind of shape and the application of the intercept theorem, we can say that d by a, this by this is equal to c by b. And that's where he calculated the height of the pyramid to a great approximation. It is almost the same height and it's calculated as 146.7 meter. He could also have used the triangle similarity if he was aware of that. There was no need to move the pole from this place to this place. So the triangle similarity theorem says that if the two triangles are similar, then their ratios are also same. So the same thing, d by a is equal to c by b, and with this triangle similarity also he could have got the same height of the pyramid as 146.7.